Good afternoon, everyone. Let us start. Today we shall conduct a new chapter, chapter 3, latitude, longitude, and time. Now I shall present my screen. We shall conduct practical till tomorrow. Then after that it will be followed by these theory classes. Okay. So here this is the new chapter 3, latitude, longitude, and time. First, let us read. Okay, see, I think you may be familiar with the terms like parallels of latitude and meridians of longitude. So, what do you mean by these parallels of latitudes? Let us read. The parallels of latitude refer to the angular distance in degrees. Okay, then minutes and seconds. Just see the symbols. Okay, of a point north or south of the equator. The lines of latitude are often referred to as parallels. And meridians of longitude. The meridians of longitude refer to the angular distance in degrees, minutes, and seconds of a point east or west of the prime meridian, that is Greenwich. Okay, meridian. Lines of longitude are often referred to as meridians. Now let us see this diagram. Okay, here this is the equator. I think you may be seeing. Okay, this is the equator as indicated here, and here if we draw a line here. Okay, so if we draw a line here, then the angle formed here is known as the angle formed between this line and the equator here. Okay, so this is the equator, and see from the center, so this is the center of the earth, and from the center if we draw a line towards the surface of the earth, okay, then the angle formed between the this equator and the line is known as latitude. Okay, let us say the angle formed here. Okay, the angle formed here is 10 degree. Then after reaching this line on the surface of the earth, okay, so we are drawing a line around the globe, and this line is known as the line of latitude or parallels of latitude. So in this way, okay, if we draw another line from the center, okay, from the center towards the surface, then after reaching the surface, then another line is drawn. And if the angle formed here is 20 degree, then so this is what we call 20 degree north. And what is this? This is 10 degree north. Okay, so in this way, here is already drawn. Okay, so a line is drawn here, and this line forms an angle of 30 degree here. Okay, 30 degree between this equator and this line, and after reaching this line, okay, to the surface of the earth, then say we have to draw a line around the globe. Okay, and that line is known as 30 degree longitude. Okay, so this is the meaning of these parallels of latitudes. Just remember, parallels of latitudes refer to the angular distance in degrees, minutes, seconds of a point north or south equator. Okay, angular distance, just as I told you earlier. angular distance between the equator and another line. Okay, north or south of equator. And likewise, see for the longitudes, lines of longitudes. See, this is the prime meridian. Okay, this is the prime meridian. That is the 0 degree longitude. And here, say if we draw a line from the center of the earth towards the surface, then the angle formed here is known as longitude. Okay, let us say this angle is 10 degree, maybe say for example 10 degree west. Okay, 10 degree west. Then this line, after reaching the surface, we have to draw a line like this. Okay, and this line is known as lines of longitude or meridian. And likewise, we can draw this 20 degree meridian. Okay, then this is 30 degree, this is 40, 50, 60, and so on. Okay, are you clear? Any question?
No, sir.
Okay, let us proceed. And now let us compare the parallels of latitudes and the meridians of longitudes. Okay, let us compare. So let us read this. The first column tells about these parallels of latitude, and the next one meridians of longitude. Okay, let us read the first point. Latitude is the angular distance of a point north or south equator as measured in degrees that we have read earlier. Okay, angular distance between of a point. Okay, angular distance of a point maybe north or south equator measured in degrees, minutes, and seconds. And for the longitude, it is the angular distance along the equator, okay, measured in degrees, and it is measured east or west of Greenwich. That is the prime meridian, 0 degree, okay, longitude, from 0 degree to 180 degree. So this is what we call longitude. Then the second point of difference, these all latitudes are parallel to the equator. Okay, just you may see here. So these are the, okay, these are the parallels of these latitudes, and these are, all these lines are parallel to the equator as you see here in this diagram. Okay, all these are, all these are parallels, and these are parallel to the equator. Equator is here. Then all meridians of longitude converge at the poles. See here, all these lines are meridians, and all meridians of longitude converge here. Just see here at the north pole or at the south pole. So all these lines are converged at the north pole or at the south pole. That means all the meridians converge at the poles. Then the third point, on a globe, third point, okay, on a globe, parallels of latitude appear as circles, as you see here. So all these are parallels of latitude, and it forms a circle when we see on a globe. And all the meridians of longitude appear as circles running through the poles. Okay, just see here, and this is the globe, and all the meridians will form a circle in this way. Just see here. Okay, let's see here. Then the fourth point, the distance between two latitude is approximately 111 kilometer. So the distance between two latitude here, for example, actually here we have interval of these 50, 10, 10, but the distance between the two parallels is, say for example, this is a parallel and this is another parallel. For example, it may be this may be equator, and let us say this is 1 degree north, and the distance from here is 111 kilometers. Okay, that means the distance between the two latitudes is approximately 111, and the distance between two longitudes is maximum at the equator, as you see here. Okay, the distance, for example, here we have the equator, and the distance between the two longitude is maximum at the equator here, and it is minimum at the poles. Okay, and so at the equator the distance between the two longitude is 111.3 kilometers, and it is minimum at the pole, that is it is 0 at the pole. And at around 45, okay, midway, at around 45 here, okay, along this line, it is around 79 kilometer. Okay, at the equator the distance between the longitude is 113 kilometer, and at the equator it is 0 kilometer. Okay, then the fifth point, the 0 degree latitude is referred to as the equator, and the 90 degree as the pole, that we have learned earlier. So this is the equator, 0 degree, and the north pole is here 90 degree. And for the latitudes, okay, there are 360 degrees of longitude. Okay, altogether, in a circle we have 360 degrees of long of degrees in a circle. Like that, we have 360 degrees of longitude, and 180 degree east in the east and the west of the prime meridian. So here we have the prime meridian, and east of the prime meridian we have 180 degrees, and the west of the prime meridian we have 180 degree, and this is known as east, and this is west. Okay, then next point, the latitudes from the equator, okay, from the equator to the poles are used to demarcate temperature zones, that is 0 degree to 23 half degree north and the south as the torrid zone that you have learned in the previous classes. Okay, and between 23 half degree to 66 half degree as a temperate zone, and from 66 half degree to 90 degree as the frigid zone. Just see here, 20 is here, okay, 20 is here, and around here, that let us say this is 23 half degree north, and this line is known as tropic of this Cancer. Okay, and in the southern hemisphere also, here we have tropic of Capricorn. Okay, tropic of Capricorn, and the areas, okay, the areas between the tropic of Cancer and the Capricorn is known as torrid zone. And here we have 66 half degree here. This is known as Arctic Circle, and here we have Antarctic Circle, and this area is known as temperate zone, and the area within the Arctic Circle, that is 66 half degree here, is known as frigid zone. So in this way, latitudes are used to divide the whole globe into zones, okay, temperature zones, as you have learned in the lower classes. Whereas for the longitudes, okay, these are used to determine the local time with reference to time at the prime meridian. So longitude here, so these are used to determine the local time. All these are used to determine the local time, okay, with reference to the prime meridian. So these are the main differences between the longitudes and the latitudes. And right now we have learned that longitudes are used to determine the local time. Okay, now let us read longitude and time. How time is determined using longitudes. So before we start, are you clear? Any question from your side? Okay, then if you don't have questions, then let us proceed. So the rotation of the Earth, okay, let us read the first point. The rotation of the Earth over its axis takes 24 hours to complete one circle, that is 360 degrees of longitude, that we have learned earlier. Earth is rotating from, okay, west towards the east, and it takes 24 hours to complete a circle, that is 360 degrees of longitude. And is 180 degrees of longitude full both east and the west of prime meridian. The sun does takes 2 hours time to traverse the eastern and the western hemisphere. So for example, here this is the prime meridian. Okay, let us say this is the prime meridian and these are the longitudes. These are the longitudes. And so here we have east and here we have west, and Earth is rotating from west towards the east. And see here we have 180 degree here, then 180 degree here, and 0 is here. That means, okay, say the sun takes 2 hours time to traverse eastern. So from here to here it takes 2 hours, and from here to here another 12 hours. Okay, that means 2 hours plus 2 hours is 24 hours. Okay, 24 hours. The sun traverses 15 degrees of longitude per 1 hour, or 1 degree of longitude for every 4 minutes of time. So the sun traverses 15 degree of longitude per 1 hour, or 1 degree of longitude per 4 minutes. This will be used for calculating the local time. Okay, just see. You should not forget this point. The sun traverses 15 degrees of longitude per 1 hour. Say, for example, this is 15, this is 30, 45, and so on. Okay, 60. Okay, that means say the sun takes 1 hour to traverse these 15 degrees of longitude. Likewise, see here. So this is 60, and okay, and so on. And the sun uh, takes 1 hour to cross 15 degrees of longitude, or it takes say 4 minutes to cross 1 degree of longitude. Okay, then the time decreases when we move to the east, from we move from west to the east, and increases with our westward movement. Just let us see a map. Okay, let me repeat. Time increases when we move from west to the east. Time increases when we move. Say, for example, this is the prime meridian. When we move towards the east, then time increases because uh, we are ahead of the Greenwich. And you must know that the Earth is also rotating from the west towards the east. And the time, see, and with the westward movement, okay, time decreases when we move from west towards the east. Just remember, okay, time decreases when we move from west towards the east. So when we move from west towards the east, time decreases. And when we move Okay, westward, then time increases. When we move westward, time increases. Okay, because the earth is rotating from west towards the east. And the last point, the rate of time at which the sun traverses over certain degrees of longitude is used to determine the local time of an area with respect to the time at the prime meridian. So with reference to the time at the prime meridian, time of a place is determined using this statement. Okay, you should not forget this point. The sun traverses 15 degrees of longitude per hour or 1 degree of longitude in every 4 minutes of time. So with this rate of movement, okay, of the sun, so we shall calculate, we shall determine the local time of an area with reference to the prime meridian. Okay, and remember, time decreases when we move towards the west. Okay, time decreases when we move towards the west. I think you may be seeing minus symbols also. When we move towards the west, time decreases. When we move towards the east, time increases. Just see here. Okay, that is why plus symbols are there. Okay, now let us take up some activities. Activity 1, determine the local time of city A located at 100° east longitude when the time at Greenwich, that is 0° is 12 noon. Okay, the time at the Greenwich is, the time at the prime meridian is 12 noon. Then what would be the time of city A, which is located at 100° east longitude? Location of city A is 100° east longitude. Okay, then what will be the time at this city A? And you should not forget that the time increases at the rate of 4 minutes per 1 degree of longitude east of prime meridian. Okay, so when we move east of the prime meridian, time increases at the rate of 4 minutes. Okay, at the rate of 4 minutes per 1 degree of longitude. So this is the statement. Time increases at the rate of 4 minutes per 1 degree of longitude when we move east of prime meridian. Okay. So for example, this is 0, and when we move eastward, then time increases at the rate of 4 minutes, okay, per 1 degree longitude. So first we have to calculate the difference between the Greenwich and the CTA. So the difference between this Greenwich and CTA is 100 longitude, because see here, location of CTA is 100° east. Okay, minus Greenwich is 0 is equal to 100°. Okay, and so here we have got this 100 degrees of longitude. So this is the difference between Greenwich and CTA. Then total time difference, you have to multiply this value by 4 minutes. Remember this statement. So 100 multiplied by 4 is 400 minutes. And so 400, if we want to convert into hours, then we have to divide 400 by 60 minutes. Okay, just see here. 400 by 60. Okay, that means by 6, then 36, I think 36, then 0, and here 4. So here it becomes hour. So the remainder becomes minutes. It becomes minute. The remainder becomes minutes. Okay. So in this way, so the time difference between city A and this Greenwich meridian is 6 hours 40 minutes, and that is why the local time of city A is 6 hours 40 minutes more than the Greenwich. That is 6:40 p.m. Okay, 6:40 p.m. The time at the city A would be 6:40 p.m. Okay, post meridian. Then we have another activity here. Okay, activity 2. Determine the local time of city B located at 100-degree west. So in this case, west of this Greenwich. When the time at Greenwich is 12 noon. Time remain the same, okay? The time at the prime meridian is 12 noon, but the location of city B is 100-degree west of prime meridian. And you must remember the statement. Okay, the time decreases at the rate of 4 minutes per 1 degree of longitude west of prime meridian. Okay, just see here, and here this is the prime meridian, and when we move towards the west, this is west. When we move towards the west, the time decreases. Okay, time decreases at the rate of 4 minutes per 1 degree of longitude. So this is the statement. And so the difference between Greenwich and city B is 100-degree longitude. Then the total time difference 100 multiplied by 4 is 400 minutes. Then after that we have to divide it by 60. That is we have 60 minutes in an hour. Okay, we have 60 minutes in an hour, and that is why to convert into hour we are dividing it by 60. And after that we have got 6 hours 40 minutes. And so the local time of city B is 6 hours 40 minutes less than, okay, less than that of Greenwich. That is 640, so sorry, 6:40 a.m. Okay, anti meridian. So 6:40 a.m. So this will be the time at city B. Okay, so remember these places located this east of meridian. Okay, east of this prime meridian, we are ahead. We are ahead of the Greenwich, and that is why time increases. Okay, that is why time increases. And if a place is located west of the prime meridian, then time decreases, and that means there is still a morning. Okay, there is still morning if we move towards the west, and it becomes evening. Okay, towards the east. Are you clear? Any question?
No, sir.
Okay, then let us stop here for today. Thank you very much for joining my class.
Thank you, sir.
My pleasure.